Hello, and welcome back to this Elasticsearch tutorial. In this, the final part of the tutorial, we'll learn about some of the ways we can optimize our Elasticsearch instance in order to make queries and indexing run faster and require less resources than you would otherwise. First, it's important to understand that there are two places where we can optimize Elasticsearch, depending on our needs. First, we can optimize Elasticsearch for search time, so that whenever a user types something in the search box on your website, that search is done faster and takes less resources on Elasticsearch. The other way we can optimize Elasticsearch is for indexing time. This doesn't affect the user searching on your website, but it does affect how long it takes Elasticsearch to get new documents integrated into its indexes. You can optimize one or both of these, and it all depends on you and the needs of your business. If you don't often get new documents, but get a lot of searches each day, then you should probably focus your efforts on optimizing for searches. If on the other hand, searches are few and far between, but you get new information a lot of the time, then indexing optimization should be your priority. This could be the case, for example, if you're feeding new information about sales to Elasticsearch every day, but a manager only checks that information once a month at the end of the month. Whereas a case where you would optimize for searches could be a website about a shop that gets a lot of new customers every day, but has new products only a couple of times a year, so new documents are not being indexed regularly. Which one you focus on depends on your specific business and its needs. If you'd like to optimize for searches, then there are a couple of things that you can do. You can optimize by modeling your documents to be as easy to search as possible. Some of the things that you can do here might run contrary to what you might have learned if you're used to relational databases. But one of the things that you can do when modeling a document to make it easier and faster to search for is denormalizing the document. For example, you can store all the related information within the same document so that you don't need to join this document with another document or make multiple searches in order to find all the information, like you would when joining two tables in a relational database. This is the case even if you duplicate information in several documents. For example, if you are storing information about a family, you could store for the son document all the information about the father, and for the daughter document all of the information about the father as well. This information is duplicated, but when searching, this will be much faster. You should also use keyword field types whenever possible. This is because, as opposed to text field types, keyword is not tokenized or analyzed, so only exact matches are possible. This makes it a lot faster to search for. Even though we saw that one of the things that you can do to make your Elasticsearch queries more powerful was to use scripts. Those scripts take its toll, especially when running a lot of times with a lot of users. Whenever possible, make sure that you don't use scripts and instead only use regular query language. It's also best if you can use as few fields as possible when searching. This makes it so that searches are done faster and take less time. In order to search by as few fields as possible, you could organize all of the fields that you want to search for into one field, which ties back to document modeling. Finally, another thing that you can do is that if you already know the sort of aggregations that you will get, you can pre-index this information at index time so that you don't need to calculate all the aggregations each time that you search. For example, if you have the documents for products in a store and one of the aggregations that you do is a bucket aggregation for prices and price ranges, meaning that you would get a bucket from products that you have from $1 to $50 and from products that you have $51 to $100. When you index each individual product, you can check the price that it has and create a new field called price bucket, where you would store whether this field falls into 1 to 50 or 51 to 100. This offloads some of the necessary processing time from search time to index time. This would be best if you have a lot of searches but not many indexing. On the other hand, if you get a lot of documents to index but not that many searches, you could optimize in different ways. You can use bulk requests rather than single document requests when indexing files or documents rather. This is better in terms of overhead than doing single document requests, and it will make a lot of difference when indexing several hundred or thousands or even hundreds of thousands of files at the same time. Additionally, it is unlikely that one thread will saturate Elasticsearch's ability to receive new documents to index. So you should try and use multiple threads, all posting information to Elasticsearch. This makes it so that Elasticsearch's resources are used to their fullest extent. and speeds up the time taken for indexing many documents because you will index them in parallel. Another thing that you can do is that by default, ElasticSearch has a refresh rate, which makes it so that every so often ElasticSearch checks for new documents and makes them available for searches. However, if you're in the process of an active indexing, then it might not be necessary to refresh the index just yet, and this will cause slowdowns. So you can increase the refresh rate, or even stop it altogether when indexing and reset it after once you're done indexing. Finally, another optimization that you can do is to use auto-generated IDs for your documents. If you don't send an ID for a new document, then ElasticSearch will generate an ID for it. The difference is that when you send an ID for a document to index, ElasticSearch needs to check that this ID doesn't already exist within its index, which can take some time and slow things down. But if ElasticSearch is allowed to auto-generate the ID, then it knows, or at least assumes, that this is a new document and will never check for an existing ID. This makes indexing go faster. Like I said, which ones of these you apply to your ElasticSearch cluster depend on your own needs and your own priorities, whether you want searching or indexing or both to be faster. Although some things, like pre-indexing information to make searches faster, offload some of the processing time from search to index and might be counterproductive if you index more than you search for.